Hi everyone, my name is Walid. In today's video I am going to show you how we can design a pond. So these are our first start that we are going to design, and let's start from the InfoDrainage. So I have this InfoDrainage model, and we will see how we can design a pond in InfoDrainage, and we also have this information that we will follow. I will show you as we go forward. So let's get started. So as you can see, I am in the InfoDrainage. I have this model, so I would like my pond to go here because this is upstream and then this is a downstream. But before designing a detention pond, we have to calculate the limit of discharge, that what is our limit. Like we have to calculate our discharge limit. Discharge limit means is to check how much this side is the runoff from this side. It will go outside our construction site. So before the development, that is pre-development, and then we have a post-development. So pre-development discharge should not be post-development, sorry about this, the post-development discharge should be less than or equal to pre-development. So first of all, we are going to see what is the pre-development discharge, that is our limit of discharge. So we will see how we can do for this side. I will first quickly analyze my site to the area of my site. So I will just go to the inflow summary. So the total area of the site is 4201. So I can just write it here, 4201, like 4.2. So this is my site total area. And we will go on to the top, prelim sizing, and from here you can see the UK ruler and runoff area. From here we have 4.201, and then you can directly select from this map the location of your site. For example, any location you have, you will select and this will automatically filled, but I have my values here, that is 623. So 623, and the soil is 0.450 and region is 6, I guess. Yeah. And we are it says urban is 0. It's because it's currently pre-development. We don't have any of the permeable surfaces, so we just leave it as it is. And the return period is 0, and return period is 30, and we are going to use this one, that is 16.1. So this is our pre-development. So we will just write it here. Should be fine. So now we have 16.1 liters per second, and so 16.1 liter per second is our limit. So I will just quickly close this one, and now I want my pond here. So in order to design a pond, first I want to calculate to see what is the outfall is. So this is my link pipe. So I will just double click on this one, and it comes, and with this highlighted area, that one is selected. So this is the upstream cover level, means this one is upstream cover level. So as I am planning to design my detention pond here, so and it will outfall into this node. So this is our discharge point. So this is 32.309. So we will just use this one. So I will just go here and another node, 32.309 outfall point, just to remember this one. And what I will do, I will just delete this link. And how we can create a pond is from here. You can see the stormwater controls, and we have a pond here. What I can use is drag here and then start digitizing. But this is one method, but I am not going to use this one. I will just see. First I will import the surface, background surface. So let's see how we can import this one. We will import it from here, right click, load surface, and load from. I will have, let's say, trimmed surface. Now we have the background surface and we don't want to visualize this one, so I will just remove, I uncheck it, but it's in the background but it's not here. And I can also show you now we will also import our outline, the CAD data. So I will also use CAD data to import my pond outline. So you can see this one, and now I have my pond outline as well. So this is outline I'm going to follow. So this is the pond that I will drop, and I will just snap on this one. As you can see, I don't have my snap mode on, so I will quickly turn on my snap mode and then start snapping, so that we will have properly. And inside the pond, right click, it will automatically close, and now right click, select tool, so that we are not going to mistakenly create another clicks. So now I have my pond here. I will just double click on this one to see its settings, and now we have the exceedance level that is the top level, that is the maximum level we have copied, that is 32.309. and I will just write it here, 32.309. and then, for example, if we have to put two values and it will commute one value automatically. So I have the exceedance level that we have seen from this one, and I also have the base level. So I ask the computer to calculate the depth for me, and then from the base level is 30.434, that is the base level, 30.434. so I will just click outside and like press enter. It has automatically calculated 1.875 depth. You can see the depth I have 1.675 here is because this depth is to the water table, to the top water level. So this is from this point to this one, and we have a 200 millimeters of freeboard. So if we calculate the freeboard, it will be 1.875. Hope that makes sense. And we have the freeboard of 200 millimeters. Now initial depth is, for example, if you are designing for a retention pond where the water at some level stays all the time, then you can put some value, but I am designing the dry pond or detention pond, so I will just leave it as a 0. Now in the table you can see that we have a pond here, but we have to make some changes as we are going to design for 1 in 4 slope. 1 in 4 slope is helpful because it's not very steep. If someone accidentally fell into the pond, they will be able to came out of the pond. So we will do the depth 1.875. we have the area that we just copy from here to paste it here, and it has also calculated the volume. But now the pond is rectangular, or you can say square, but we want the slope. So for the slope we can do its sizing calculator. From the sizing calculator we can do the side slopes, that will be 1 in 4. It has, let me have a look, maintain the top area, side slope 1 in 4. Yeah, now we have the volume of our pond. I will also go through it quickly to see if everything aligns. So 1.4 is the area, and then this one is the pond. and then this is side slope, maintain area, top area. Yeah, so all good. And then we also have to do Manning's roughness. Manning's roughness is always important. So this is the Manning's roughness we have here. As you can see, I have the pond design as per the sizing calculator, but there are other things that we can also see. You can see this is the bottom line of the pond, and then this is the top of the bank. Now we will see how we can calculate our discharge, our runoff coefficients and percentage impervious values. That will also help us in our calculations. So for the PIMP values, we will just go to the tables. You can see the tables. We will double click the table, and from this one I just need the volumetric runoff, not the time of prelim percentage. So so now I have the percentage impervious values. So mostly development sites are 60% impervious and 40% is the pervious area. So PIMP values is mostly the percentage impervious values is 60%. So we will just going to change these values to 60. Also change these values to 60. Also make sure that we have changed all the values. And the volumetric runoff is basically during the dry period. So dry period, the surfaces are dry and water will like evaporate quickly. So this is like 0.750 is like 75%, like all of from this channel 75% of the water will flow into our pond. So this is 75% means, and in the winter obviously the surfaces are wet, so all the water goes into the pond is 84%. So these are the values according to that. So that's, I'm happy with these values, and we have also updated our percentage impervious values. So I will click OK. Now it is updating the data, and I can show you in the quickly inflow summary. So previously you have seen that this was 4.2 and this one was also same, but now the area analyzed is reduced to 22.5 to 1. So it means that it's now negative 40% has been deducted. So as we have updated our percentage impervious value, so this will only consider our impervious surfaces. So this is 2.5 to 1. Going forward we are going to use this one, 2.5 to 1. I will also note this one here, 2.5 to 1 analyzed area. So so this is we have updated, and also now we have to calculate our stage storage. So the stage storage is the quick storage estimate that our site has the like quick estimate of the water flows into the pond. So we can calculate that as well. For the stage storage you have two methods. Once you can do it from the prelim sizing and you can see quick storage estimate, or I will just do it directly from the pond. This will make the pond volume change as well. So if we can able to better see this one. So from the here you can see the sizing calculator. Again we are going to the sizing calculator. So now I am going to do the quick storage estimate, design up to the exceedance level or the freeboard. So I will keep it to the freeboard because I don't want to design at the exceedance level. At least give some freeboard, because above the exceedance level that means it's flooding. So I will just calculate the volumes, and here it asks for the input data, use plan data, or I will put manually. So the value is we put here will be the analyzed value after our percentage impervious values. So that was this one, 2.5 to 1. So 2.5 to 1, and then volume at rig runoff is 0.750, that is 75%. And discharge limit we have is this one that we have calculated in start. And the infiltration rate, for example, if your soil is sandy, so you can put the infiltration factors as well from your geotechnical reports, but here I'm just leaving at 0. And I have the rainfall data from my library. You can use your own rainfall data. If you work in Australia, you can use that. If you work in USA, you can use the NOAA rainfall data. So this I'm using FSR. In UK, you can use FSR and FEH, so whichever you like. So this I am just designing a pond. So looks good to me. I will click OK. And the volume, we didn't calculate. Yeah, so we have to click on the calculate in order to calculate the volumes. So it has roughly estimated this one. So this is always a rough estimate. This is not the exact values. So exact values we will get after we run the simulation, we run the analysis. So this is a rough value, and I will just click OK. Now it has come with the average value, that is 851. So I will click OK. Now you can see the volume has been updated, because now it has also calculated the quick storage estimate. And once I will apply, you will see in the plan view that the size is now increased, then this will also increase in the plan view. So just keep an eye on this one. So I will click apply. You can see this has been now it is bigger, and this was our previous CAD data that we used. Now the size has been increased. So I can just do is just turn off the layer, CAD layer, and yeah, so I will click OK. So 1000. As this is our pond is ready, now we need to connect the inlets and then the outlet. So we can do it directly from the build tool, like we can just add a pipe and click here, or I also have the CAD data for the layout where we can do the connections. So in this way we will also see how we can import the shape files. So I will just going to import the shape file, and I have the pipe outline. I think this one. So it will load, taking a little bit of time. Shouldn't take long, but yeah, we will see. And then we will just start connecting our pipes. No, not this one. I think I have loaded the wrong one. So should have the outline. I have pond pipe. Or we can just I would say we can just do the direct one, pond pipe, pond outline. Yeah, this one is the pipe networks, the DXF file. So and after that we will connect our inlet, and then yeah, this is a file. So I will click finish. Now you can see I have the CAD data, and you can draw the connections from your left side from here, the connections, or you can just do it from here as well. Add connection, pipe. You can see this blue one. So I will zoom in. So this is my manhole, and snap mode is on. I will click here, and always make sure you click first this one, and then this is our outlet to this one. You can see if my mouse is down, it says inlet. Mouse is up, it says new. So this is inlet. So I will click this one, and you can see this sign shows us the inlet, and this connection shows that this is our outlet. So right click, select tool, so that we are not connecting anything else. and I will just double click on the pipes because I can see the pipes are a bit different. So this pipe 1 and pipe is the new pipes, so I will change it to 600 as the rest of the pipe networks. Oops, sorry, I will just drag it back. 600, click OK. Now the styling has also been changed, so I can see that these are the 600 pipes. Now if I will click on the pond, and then I have the inlets that we have connected, so it's a point inflow, that's fine. And then outlet, so outlet says it's a free discharge, but I want it an orifice so that we have some control. And so we will just drop down from here, go to the orifice. You have other options like hydro brake, weir or anything, and we will also see how we can do the weir. So this is the weir. Let's calculate the diameter. As if you know already, then you can put it here, or we will just size calculate. And this asks us the design depth and the design flow. So design depth is 16.1, and here we can have our design depth that I think was what was the 32 1.875. Let me have the balance. So the freeboard point is 1.675. So I want like my orifice is 1.675 and the discharge is 16.1. So I am putting these values not to the freeboard. So this comes up with 0.077 is the orifice diameter, and I'll just click on OK, and the invert level is automatically from the pond. So this is from the pond. Click OK. Now that you can see the design has been changed to the orifice, and now I want another connection here, that is the weir. So weir will help us in case of emergency. So in case of extra water into the pond, it will overflow from the weir. So this is an emergency exit for the water. So we will design the weir as well. In order to design the weir, I will put a simple junction from the junction. You can see from the junction, simple junction, and just click into this snap here, and then right click and select mode. To connect with the junction, we have another connection, that's no delay connection, and snap here to this one. So no delay connection is like it tells the software that is the same thing, it's not a pipe. Anything that goes up, it will fall into the outside the pond. So this is shows that simple junction, and the no delay is like same thing into the pond. So this is where we use no delay, we don't use pipe. And but here I can see that this is again a weir, again orifice, but we want weir. So I will just double click on the pond and go to the outlets. You can see we have another outlet that names outlet 1, connection is no delay, but type is orifice. I want it to be a weir, and the depth is 3.00. The crust level, so the crust level is basically, this is the weir, so water is coming here, so this is the top of the weir, and this is the crust level, after which the water will pass. So the water will be coming from here, and it doesn't passing. So after the level, this is the level, crust level. So after this level, the water will flow outside the pond. So this, the top level of the weir is called the crust level, after which the water starts to go through the weir. So this is the level we want, is the exceedance level that we have. So what we have, the exceedance level 32.309. 32.309. I would say, yeah, I should design after the freeboard, or should I go for the freeboard? I think freeboard is after the freeboard. Okay, we will see. Also, I will just click it. Okay, so this is how coefficient remains the same. So now you can see the icon has been changed to Weir. Now our setup is ready, our system is ready. I will just quickly save it, and now we have to run the simulation in order to see how our pond is working. Is it proper or is it not proper, or we have to make any changes. So first we need to create a flow path in order to run the simulation. So here is a flow path, add, and from the upstream to the downstream. Also, I want to say that whenever you are designing the connection pipe networks, make sure you design from upstream to the downstream. Otherwise you have to reverse your flows or other things. And right click select. So this is my flow path is now ready. Now I will go to the analysis, and to see my analysis settings, my rainfall criteria. So I will use this rainfall. Interval should be 2 because I'm designing a pond, so better calculation. Shortest distance. Again, the rainfall data, you can use your own rainfall data. I will click OK. Again, go to the analysis, validate. So it says level cannot be equal to, so again we should design it. So this is the good thing about in InfoDrainage, they also tells us what are the limitations. So sorry about that. So I will just double click my outlets, my Weir design to the freeboard. Click OK. Analysis, validate, everything is okay. We will run the simulation. It's running the simulation. It will take time, and then it pops up a table that to show how we performed during this period. Now I need to go to the critical storm events, and for this is the stormwater control pond, and you can see the percentage available is 7%. It's still bigger because this we run for the critical storm is 7%. We don't want a bit bigger. We can make it a bit smaller so that we can save some space. And for that one, what we can do is double click on the pond, and this is the volume. So we have to change the volume. Again, we have to run the simulation. Sorry about it. So analysis, go to the analysis. So we will see how much volume our pond can attenuate, or the volume that comes. So critical storm, you can also select the all storms. This will comes with all storm, and then highlight the critical storm. So this is a maximum resident volume that we have is 792, and so this is the volume is on the side. So I can say that 794, or we can put 795. So 795 would be will be fine. So I will close this one, go to my pond, click on this one, sizing calculator. So change it to 795. So it should be now. Click OK. Now the pond has been a little bit changed. Now again go to the analysis, validate, all good, run the analysis. I hope this will make perfect. So this is how you can create the pond with your Orifice, with your Weir. And if you guys have any questions, you can ask in the comments. And for this one, you can see 57% available. Again, remember we are analyzing for the critical storm. Click on the critical storm. This is a critical storm, winter storms. And here now you can see it's only 1% available. So I think this is better. even for the critical storms. And if you click all storm, then this one, like some storms where is 3%, so 1%, this is the best for the critical storm, and you will have no flooding even in the critical storm. So this is it. I know that this is a bit longer video, but if you guys have any questions, you can ask in the comments. We'll be happy to answer. And if you want some other videos on this one, just ask in the comments. Till then, bye, take care, peace out. Thank you for watching.